What if everything you see around you, stars, planets, your phone, even your own body, isn't actually made of particles? For over a century, we've been taught that the universe is built from tiny building blocks called particles, electrons, quarks, photons. These invisible pieces were thought to be the fundamental ingredients of reality. But scientists now say that's not the full story. In fact, some of the latest discoveries and deeper understandings in physics point to something even more astonishing. Particles may not be the true foundation of the universe at all. Instead, according to modern quantum physics, everything that exists emerges from invisible entities known as quantum fields. These fields fill every corner of space, stretching across the entire cosmos. They are always present, even in what we call empty space. And here's where things get strange. An electron isn't a tiny ball flying through space. A photon isn't just a particle of light. What we perceive as particles are actually tiny ripples, vibrations, or excitations in their respective quantum fields, similar to how a wave appears on the surface of an ocean. Think about that for a moment. If quantum fields are real, then the universe isn't made of objects moving through empty space. Reality itself is more like a vast network of invisible fields interacting with one another, constantly fluctuating beneath the surface of everything we observe. This revolutionary idea has transformed our understanding of nature and forms the backbone of the most successful scientific theory ever created, quantum field theory. But what exactly are quantum fields? Where did they come from? How do they create matter, energy, and the forces of nature? And could they reveal the deepest secrets of reality itself? In this video, we'll explore the fascinating world of quantum fields, uncover how scientists discovered them, and see why many physicists believe they are the closest thing we've found to the true fabric of the universe. Get ready, because reality is far stranger than it appears. For hundreds of years, science built a very comfortable, very solid picture of reality. It was a mechanical world made of fragments. If you looked at a stone, a tree, or a human hand, the old masters told us that these objects were constructed out of tiny, indivisible marbles. They called them particles, a word that conjured images of microscopic grains of sand, hard and distinct, flying through a passive, empty void. In this old view, space was just the stage, a grand, dark, hollow theater, and the particles were the actors moving across it, bumping into each other like billiard balls on a green felt table. It was a neat, orderly universe that made perfect sense to our minds, because it looked exactly like the world we touch every day. But as the instruments in our laboratories grew quieter and more sensitive, that mechanical clockwork world began to dissolve. The little solid marbles that everyone expected to find at the bottom of reality started to soften. They refused to stay in one place. They refused to act like things at all. Imagine holding a handful of pebbles and tossing them one by one through a narrow gap in a fence. If you do this for an hour, you expect to see a single concentrated pile of pebbles on the other side, directly behind the opening. That is how objects behave. But when physicists began firing individual electrons through microscopic slits, expecting them to pile up like tiny stones, the universe gave a completely different answer. If no one was looking, a single electron fired into the dark chamber did not travel along a straight, neat line. It did not choose a single path. Instead, as it traveled, it seemed to blur, spreading out through space like the ripple made by a heavy drop of rain on a black pond. When it encountered two parallel openings in a barrier, it did not go through the left or the right. It drifted through both simultaneously. It rolled through the spaces, met itself on the other side, and interfered with its own shape, the crest of its wave lifting itself up in some places and canceling itself out in others. By the time the electron finally arrived at the far wall, landing with a sharp, solitary click, it had left behind a fingerprint that shattered the old physics. When millions of these clicks were mapped over time, they did not form two neat rows of particles. They formed a beautiful, rhythmic pattern of alternating stripes, the classic signature of overlapping waves. An entity that we had spent a century calling a solid piece of matter was, in its lonely journey through the dark, behaving entirely like a ripple on water. The world was not a collection of tiny bricks. The bricks were an illusion. The true architecture of the cosmos began to reveal itself through the mind of a quiet, fiercely mathematical thinker named Paul Dirac. In the late 1920s, Dirac sat alone with his equations, trying to reconcile the strange, fluid laws of the subatomic world with Albert Einstein's principles of high-speed relativity. He was looking for a mathematical description of how an electron moves when it approaches the speed of light. When the mathematics finally came together, settling into an elegant balance on the page, Dirac noticed something strange. The equation worked beautifully, but it refused to describe just one isolated particle. Every time he solved it, the math insisted on a double answer. It predicted the existence of the ordinary, negatively charged electron we all know, but it also pointed to a shadow, a mirror image that was identical in every single property, from its weight to its size, except that its electrical charge was entirely positive. Dirac had not just described a single grain of matter flying through space. His mathematics had inadvertently tapped into something much larger, a continuous, universal field that spanned the entire cosmos. The electron was not an independent object that existed on its own. It was merely a localized disturbance, a small, concentrated knot of energy in a grand, invisible tapestry. And that tapestry had two sides. Within a few years, experimentalists looking at the high-energy debris falling into our atmosphere from deep space caught this mathematical shadow on film. They found the positron, the antimatter twin of the electron. It was real, it was perfect, and it confirmed a profound truth about the fabric of reality. Matter was not fundamental, the field was fundamental. To understand what this means for the reality you can see and touch right now, we have to change the way we visualize an object. Think of a deep, perfectly still mountain lake at midnight. The water is pitch black, invisible to the eye, blending perfectly with the dark shores. If you stand on the edge, you cannot see the lake itself. You only know the water is there when a trout breaks the surface, or when a heavy leaf falls from an overhanging branch. When that leaf hits the surface, a ring of ripples expands across the dark water. You point your finger into the darkness and you say, "Look, there is a wave." You watch it glide across the lake for a few moments, catching the faint starlight until it eventually loses its energy, flattens out, and disappears back into the stillness. When the wave is gone, where did the thing go? What was it made of? It wasn't made of some unique substance called wave. It was made of the lake. The wave was never an independent object. It was simply a temporary behavior of the water. It was a shape that the lake chose to take for a brief moment in time before returning to its resting state. This is what an electron is. This is what a quark is. This is what light itself is. The universe is not a vast, hollow warehouse containing a collection of traveling particles. The universe is the lake. Space is filled to the brim with an electron field, an unbroken, universal ocean of potential that sits quietly inside your chest, inside the core of the Earth, and in the freezing expanses between galaxies. When the universe wants to create an electron, it does not fetch a tiny ball from somewhere else. It simply disturbs the field. It plucks the fabric. A small, localized ripple appears, moves through space, and interacts with other ripples. We look at that ripple through our instruments, we see its concentrated energy, and we give it a name, a particle. But there is no particle there. There is only the ocean, moving. Because every electron in existence is made of the exact same underlying ocean, a strange, beautiful harmony emerges across the cosmos. If you were to gather two electrons, one harvested from a carbon atom inside your own eye, and another pulled from the burning heart of a star 3 billion light-years away, and compare them in a laboratory, you would find something haunting. You could measure their electrical charge to 15 decimal places. You could weigh them on the most delicate quantum scales. You could test the way they spin in a magnetic field. You would find that they are not just similar. They are not just identical twins. They are perfectly, flawlessly, eerily the same. In the macroscopic world, no two things are ever truly identical. Every grain of sand on a beach has a microscopic chip or a unique hue. Every snowflake forms a slightly different pattern as it falls through the cold air. But electrons have no individuality. They have no history, no scars, no identifying marks. Quantum field theory explains this mystery with absolute, calm simplicity. The electron in your eye and the electron in that distant star are identical because they are the exact same medium in motion. They are two separate waves rising out of the same single, continuous cosmic sheet. When a field vibrates in New York, and when it vibrates on the edge of the observable universe, it produces the exact same note because it is the exact same string. The universe is a single, cosmic instrument playing a song made of a dozen notes, and everything you see is just the music vibrating through the room. And these fields do not just coexist, they talk to one another. And the Earth would be a frozen rock drifting in a pitch-black void. The stars only shine because the protons can tunnel. As two hydrogen nuclei rush toward each other, their waves meet and begin to repel. But because they are ripples on a field, their shapes blur. They do not need to climb over the energy barrier. They simply leak through it. Every single second, trillions of protons inside the sun perform this ghostly trick, slipping through the electrical wall, fusing together, and unleashing the torrent of energy that lights up our sky. The sunlight that falls through your window during the day, the warmth that grew the food you ate tonight, the energy that drives the weather systems of our entire planet, all of it is a direct gift from the fluid, blurry nature of quantum fields. We exist because the world is made of waves that refuse to be contained by walls. As you lie here in the stillness, let the scale of this realization expand in your mind. We are so accustomed to thinking of the universe as a collection of separate pieces, because that is how we experience our lives. We feel lonely, we feel small, we feel like isolated consciousnesses, trapped inside a fragile envelope of bone and skin, looking out at a vast, distant world that has nothing to do with us. But the mathematics of the fields tells a deeply comforting story of unity. Think of a grand, elaborate tapestry woven from a dozen different colors of silk thread. If you look at the tapestry from a distance, your eye catches the shapes depicted on its surface: a tree, a cloud, a human figure. You point to the tree and you say, that is a distinct object, separate from the cloud. But if you move close enough to touch the fabric, if you look at it through a magnifying glass, the boundaries disappear. You see that the tree is not a separate thing at all. It is just a collection of green threads that weave seamlessly into the blue threads of the cloud and the brown threads of the earth. The entire image is made of a single, continuous, interconnected web of silk. You cannot pull on a thread in the tree without disturbing the shape of the cloud. This is the true picture of the room you are sitting in right now. Your body is a dense, intricate knot woven into the universal fields. The electron field that is vibrating inside your brain, generating the quiet, rhythmic thoughts that are helping you drift off to sleep, is not a private, isolated piece of property. It is the exact same sheet of fabric that stretches out across the floor, passes through the walls of your house, rises up into the atmosphere, and reaches across the black expanses of the solar system until it touches the furthest, cold galaxies at the edge of the visible world. There is only one electron field in the universe. There is only one photon field. There is only one Higgs ocean. We are not separate travelers walking across a stage. We are different features carved into the same single, continuous canvas. We are the universe experiencing itself through different ripples. This means that you are never truly alone. and you are never truly separate from the cosmos. The distance between you and a star in the constellation of Orion is not an empty, dead waste of nothingness. It is a rich, living highway of overlapping fields, a continuous medium that connects your skin to the furthest reaches of space. When a star explodes in a distant corner of the universe, it sends a massive shudder through the photon field, a wave of light that travels for millions of years across the cosmic ocean until it finally hits the lens of your eye, disturbing the electron field inside your retina and creating the small electric flash that you perceive as a twinkling point of light. The star and your eye are 2 points on the same string, vibrating together in the dark, and this deep connectivity brings with it a profound sense of peace. The burdens we carry during the day, the anxieties about our schedules, the worries about our health, the heavy sense of individuality that isolates us from the world around us, all of these are properties of the macroscopic illusion. They belong to the world of hard surfaces and ticking clocks. But when you close your eyes and let the room fade away, you are invited to drop below that surface, down into the quiet, subterranean depths where the fields are flat and calm. In those depths, the vacuum is not a terrifying void. It is a patient, eternal presence that has been waiting for you since the beginning of time. It is the womb from which every atom of your body was born, and it is the quiet reservoir to which all things eventually return. The shivering of the fields is not a chaotic storm. It is the gentle, rhythmic breathing of the cosmos itself, a slow, permanent pulse that keeps reality alive at the edge of existence. Think of how a deep-sea diver feels when they drop over the side of a boat at night, leaving behind the noise of the wind, the crash of the surface waves, and the bright, blinding glare of the sun. As they sink down into the black water, the world above them grows quiet. The pressure wraps around them like a heavy, supportive blanket, holding them suspended in a weightless, silent world where there is no up or down, no past or future, only the slow, rhythmic sound of their own breath. They are no longer an outsider looking at the ocean. They are inside it, a part of its fluid, dark, immense peace. That is what it means to fall asleep in a universe made of fields. You are letting go of the surface waves of your day. You are letting go of the sharp, hard boundaries of your thoughts. You are allowing your consciousness to soften, to spread out like a slow, cold ripple on a dark pond, dissolving back into the continuous fabric of the cosmos. Your breath is slowing down now, matching the deep, ancient rhythm of the zero-point hum that fills the empty space around you. Your body is losing its sharpness, its weight feeling less like a solid burden and more like a gentle, resting vibration on the surface of the Higgs Ocean. The room is safe. The dark is full. The fields are holding you, as they have always held you, in a quiet, eternal embrace that knows no distance and no end. The silence grows heavier now, sinking through the floorboards, expanding outward into the cool night air until the entire neighborhood, the entire city, feels like a single, quiet room resting under the stars. In this deep stillness, the heavy machinery of the day completely powers down. The demands of schedules, the noise of voices, the relentless pressure to be a specific person with a specific name and a specific history, all of it begins to unspool like a thread pulling away from a sweater. You are left hovering in a state of pure, untethered awareness, listening to the quiet rustle of your own breathing, drifting further away from the waking world with every gentle exhalation. As the waking world recedes, the old, comfortable certainties go with it. We spent the hours of daylight operating under the assumption that the world is a gallery of finished objects. Static, predictable things that wait for us to notice them. A chair is just a chair. A window is just a window. A wall is a solid, unyielding barrier of plaster and wood. But as you sink deeper into the dark, your mind is allowed to remember the great, secret truth that modern physics uncovered in the quiet hours of the 20th century. The truth that nothing is finished, nothing is static. The universe is not a museum of solid artifacts. It is a live performance that is being improvised from one fraction of a millisecond to the next, written onto the invisible sheets of space by an author that never sleeps. To understand just how radically this changes the room you are lying in, think about the very concept of a location. In our daily lives, we treat a location as if it is a set of rigid, permanent coordinates, a little box in space where a thing belongs. You put your car keys on the counter, and you expect them to stay exactly there until you pick them up again. You lay your head on your pillow, and you believe your body is occupying a definite, sharp region of the bed. But when quantum field theory looks at the underlying canvas of reality, it reveals that a location is not a static point. A location is a state of probability. It is a question that has not yet been answered. Imagine a vast, dark theater with a polished wooden stage. In the center of the stage stands a single dancer, dressed in black, moving so quickly through the darkness that the human eye cannot track her form. She sweeps from the left wing to the right wing, leaps into the air, spins in the center, and glides along the back wall, her movements fluid, continuous, and completely unbroken. If you take a photograph of the stage with a long exposure time, you will not see a distinct person standing in a single spot. Instead, you will see a beautiful, luminous cloud, a brushstroke of white light that fills the entire stage at once, thicker in some places and thinner in others, representing all the paths the dancer traveled while the shutter was open. This is what a quantum field is doing at every single point in space. It is a field of possibilities, a landscape of potential shapes, hovering in a state of suspended animation until something forces it to choose a single configuration. When an electron is traveling through the dark interior of a vacuum tube, it does not exist as a tiny, localized bead of matter moving along a precise line. It exists as that luminous cloud of movement. It is everywhere at once within its boundary, a smear of potentiality that stretches through space like a morning fog settling over a valley. It only becomes a thing, a sharp, definitive particle with a measurable location, when it bumps into something that forces it to register its presence. When it hits a detector screen or collides with another field, the cloud of probability suddenly collapses. The wide, spread-out wave rushes inward, condensing all of its scattered energy into a single, blindingly sharp point. The dancer stops spinning. The camera shutter clicks. A single dot appears on the film. We look at that dot and we say, "There is the particle." But the particle was only a temporary event. It was the moment the field was caught in the act of moving. The true reality was the cloud, the wide, fluid wave of potential that filled the stage before the shutter clicked. The solid world we see during the day is just a collection of these collapses, billions of tiny, microscopic events happening so quickly that they blur together into the illusion of permanent objects, like the individual frames of a movie film moving past a projector light until they look like a continuous stream of life. And this fluid nature applies not just to the tiny pieces of matter inside your cells, but to the very concept of time itself. In our everyday experience, time feels like a relentless one-way river. It flows out of a past that is dead and gone, passes through a present that is gone before we can grasp it, and moves into a future that does not yet exist. We feel trapped in this current, carried along like leaves on a fast-moving stream, unable to turn back, unable to see what lies around the next bend. But when physicists began to write down the equations that describe how quantum fields interact with one another, they noticed a strange, unsettling feature of the mathematics. The equations do not care about the direction of the clock. They are completely symmetric. If you were to film a collision between two ordinary particles, say two electrons that fly toward each other, exchange a photon of light, and bounce apart, and then play that film backward, the reversed movie would not violate a single law of physics. The mathematics works exactly the same way, whether time is moving forward from Monday to Tuesday, or backward from Tuesday to Monday. The field does not experience the passage of time as a heavy psychological burden. It experiences time as a dimension of space, another direction in which a wave can ripple, another axis along which a tapestry can be woven. This symmetry led to one of the most radical, mind-bending insights in the history of science, proposed by a young Richard Feynman while he was working at Princeton University. Feynman was looking at the Dirac equation, trying to understand the behavior of the positron, the antimatter twin of the electron that carries a positive charge instead of a negative one. He noticed that if you take the mathematical description of an ordinary electron moving forward through time and mathematically reverse the direction of its clock, the electron transforms perfectly into a positron. A piece of antimatter was not a different kind of material found in some exotic corner of space. A piece of antimatter was simply an ordinary particle traveling backward through time. Imagine a long, winding highway that runs through a mountain pass. You are standing on a high cliff overlooking the road, watching a single car travel along the pavement. The car drives forward for a mile, hits a sharp hairpin turn, reverses its direction, and drives backward along a parallel lane for a short distance, before hitting another turn and traveling forward once again. If you can only see the highway through a narrow slit in a cardboard screen, a slit that represents the single fleeting moment we call the present, you will not see one car making a zigzag journey. Instead, when you look through the slit, you will see three distinct cars occupying the road at the exact same time, two of them traveling forward and one of them traveling backward. Feynman realized that this is exactly what happens when we observe the creation and destruction of matter in our laboratories. When a high-energy photon of light strikes a field, creating an electron and a positron that fly apart, we think we are seeing the birth of two new entities. But the mathematics suggests something far more poetic. We are seeing a single traveler hitting a hairpin turn in time. The electron that is traveling forward into the future suddenly suffers a collision that bounces it backward into the past. As it travels backward through time, it wears the mask of a positron. Then, it hits another collision in the past and turns around once again, traveling forward into the future as an ordinary electron once more. The trillions of electrons and positrons that fill the universe are not an army of separate individuals. They are the threads of a single cosmic needle, weaving back and forth through the fabric of time, crossing the present moment again and again and again, creating the illusion of a crowded, material world out of the endless journey of a solitary traveler. Think about the comfort of that image as you lie here in the dark. The history of your life is not a collection of moments that are constantly dying, lost forever to a past that disappears behind you. Every moment of your life, the breath you are taking right now, the first memory of your childhood, the quiet dreams you will have tonight, is a permanent structure carved into the multidimensional fabric of the fields. The universe does not erase its work. It simply builds a shape that is wider than our eyes can see, a grand, timeless architecture where the past, the present, and the future are all coexisting at once, like the notes of a grand symphony that are all written on the same page, waiting for the conductor's hand to bring them into the light. And as you drop further into the stillness, you can begin to feel the sheer, silent weight of the ocean that gives everything its substance. The Higgs field. For decades, the Higgs field was the ghost of modern physics, an idea that existed only on paper, dreamed up by a handful of theoretical thinkers in the 1960s who were trying to solve a desperate crisis in our understanding of matter. When they wrote down the equations for the universal fields, they found that the mathematics only worked if all the particles in the universe were completely weightless. According to the pure, unbroken symmetry of the laws, electrons, quarks, and all their cousins should fly through space at the absolute speed of light, never slowing down, never binding together, never forming atoms or molecules or solid ground. The universe should have been a restless, weightless phantom, an eternal flash of ghosts moving at the speed of light. To fix this flaw, a Scottish physicist named Peter Higgs and his colleagues suggested that the universe had been submerged in a secret reservoir. They proposed that shortly after the Big Bang, a new kind of field woke up across the cosmos, a field that did not sit at an energy value of 0 like its brothers, but instead filled the entire vacuum with a thick, uniform, heavy presence. Think of a vast, frozen continent covered in a deep layer of pristine snow. If you are a bird flying high above the ground, your wings catch the air and you glide effortlessly through the sky, completely unbothered by the winter landscape below. You are like a photon of light, weightless and fast, moving through the universe without ever interacting with the Higgs field. But if you are a traveler on foot, stepping off the edge of the forest and wading into the deep snowdrifts, your experience changes completely. As you try to run, the snow packs around your boots, resisting your acceleration, demanding an immense effort for every single step, slowing you down until your movements become heavy, deliberate, and slow. The snow has given you weight, it has given you inertia. This is what the Higgs field is doing to the ripples of your body at this very instant. The quarks that form the protons inside your heart, the electrons that carry the electrical signals through your nervous system, they are all travelers wading through the cosmic snowdrift of the Higgs field. As they try to move through space, the Higgs field wraps around them, dragging at their shapes, resisting their changes in motion, turning their fleet, light-speed energy into the heavy, slow property we call mass. Every ounce of your weight, the heavy feeling of your limbs sinking into your mattress, the gentle resistance you feel when you lift your hand to adjust your blanket, all of it is a direct measurement of how tightly the Higgs Ocean is gripping the ripples of your existence. You are not heavy because you are made of solid stuff. You are heavy because you are a pattern of energy that is deeply loved by the vacuum, held tight by an invisible fluid that refuses to let you fly apart at the speed of light. For 50 years, this beautiful idea remained an unproven rumor, a mathematical fairy tale told in university lecture halls. To confirm it, humanity had to build the largest, most complex machine ever conceived by our species. A giant ring of superconducting magnets buried 100 meters beneath the hills of Switzerland and France, 27 kilometers in circumference, designed to smash protons together at velocities that match 99.999% of the speed of light. They had to recreate the white-hot conditions of the early universe, plucking the fabric of space with such immense, concentrated violence that they could force the invisible Higgs Ocean to splash. They needed to hit the water hard enough to make a single droplet break free from the surface, a droplet that we call the Higgs boson. In the summer of 2012, after years of work, thousands of scientists, watching the data streams on their monitors, saw the droplet fall. Out of the chaotic debris of a billion high-energy collisions, a faint, unmistakable bump appeared on the graphs, a signal that a new entity, weighing about 125 times more than a proton, had flashed into existence for a fraction of a second before decaying back into the dark. It was the fingerprint of the Higgs Ocean. The announcement sent waves of emotion through the scientific world. Elderly men who had spent their youths writing down those equations in the 1960s Saturday in the audience and wept into their hands, realizing that the secret thought they had whispered into the dark half a century ago was the literal truth of reality. The vacuum was full. The snowdrift was real. The universe was exactly as strange, as poetic, and as unified as their minds had dreamed it to be. Let that triumph of human thought settle into your mind as a profound source of security. We are a small, fragile species living on a tiny speck of blue dust in a vast, uncaring wilderness of stars, and yet our minds have managed to reach down into the absolute dark of the vacuum and map the invisible currents that give structure to the cosmos. We are not strangers in this universe. We are its native children, born from its laws, engineered by its geometries, and fully capable of decoding its deepest music. The intelligence that built the stars is the exact same intelligence that is resting inside your head tonight, dreaming its way back into the silence. And as you drift closer to that silence, you can let go of the need to understand any of it. The math can rest. The equations can fade from your thoughts. You do not need to calculate the fields to be supported by them. You do not need to understand the Higgs Ocean to sink safely into its depths. Think of a child lying on the deck of a great wooden sailboat that is drifting across a calm tropical sea at night, The child does not know anything about navigation. They do not understand the fluid dynamics of the hull, or the meteorology of the trade winds, or the immense, multi-mile depths of the dark water that stretches out beneath the keel. They do not need to know. They simply lie on their back, looking up at the stars, feeling the gentle, rhythmic rocking of the timbers as the ocean carries them home through the dark. The boat knows how to float. The sea knows how to hold the boat. The wind knows how to fill the sails. The child is safe because they are a part of the journey, completely enclosed by a system that has been working perfectly long before they were born. You are that child tonight. The universe knows how to be the universe. The fields know how to shiver. The vacuum knows how to hum. The laws of quantum mechanics know how to maintain the beautiful, steady mandalas of your atoms, without a single moment of help from your conscious mind. Your heart will beat on its own. Your lungs will rise and fall on their own. Your cells will continue their silent, microscopic dances in the dark while you let go of the reins and drop into the deep. Allow your awareness to sink down beneath the level of words, down into that soft velvet region where your thoughts become images, and your images become colors, and your colors dissolve into a uniform, peaceful dark. Listen to the faint residual hum of the room, the distant sound of a car passing on the street outside, the quiet ticking of a clock, the soft hum of the refrigerator in the kitchen. In the old view of physics, those sounds were just mechanical vibrations, traveling through a dead air mass. But now you know better. Those sounds are waves in the photon field, ripples in the acoustic fabric of the air, expressions of the same continuous restlessness that keeps the entire cosmos alive. Every sound is a reassurance that the room is awake, that the universe is breathing, that you are surrounded by a living, patient presence that is protecting you while you sleep. Think of the zero-point energy, that eternal, unquenchable shiver that remains when everything else is stolen away. It is the proof that the universe can never be truly poor. It can never run out of potential. No matter how cold the night becomes, no matter how dark the spaces between your thoughts may seem, the baseline of reality is not a cold zero. It is a warm, expectant hum. The universe is a bank that can never be bankrupted, a fountain that can never run dry, an ocean that will continue to tremble with life, even if every star in the sky were to burn out and cool into ash. You are tethered to that infinite reservoir, your small, temporary life drawn from an inexhaustible well of cosmic energy that will endure forever. Let that eternity wrap around you like a heavy winter coat. You do not need to finish your story tonight. You do not need to solve the mysteries of your life before your eyes close. The fields have all the time in the world. They have been expanding through the dark for 14 billion years, turning light into matter, matter into stars, stars into life, and life into consciousness, moving with a slow, majestic patience that makes all our human worries look like the fleeting ripples of a single afternoon. As you draw in your next deep breath, imagine that you are breathing in the serenity of that endless canvas. And as you let it out, feel your worries, your plans, your memories, and your identity dissolving back into the continuous fabric of the space around you. You are becoming fluent. You are becoming soft. You are widening out, your consciousness spreading through the room like a drop of ink falling into a glass of clear water, losing its sharp edges, blending perfectly with the dark stillness until there is no difference between the silence inside your head and the silence of the night outside. The electron field is flat and calm inside your cells. The photon field is dark and resting inside your eyes. The Higgs Ocean is holding your weight with a gentle, stubborn tenderness that will never let you go. You are safe in the architecture of the fields. You are home in the music of the vacuum. The deep stillness of the midnight hour has a way of dissolving the boundaries that feel so rigid during the daylight. When the world is loud and moving quickly, it is easy to look at the objects around you and see them as independent entities, completely isolated from one another. You see a lamp on a table, a glass of water on a nightstand, and the frame of your bed as distinct pieces of a fragmented reality. But as the night deepens and the ambient noise of human life recedes, your mind is allowed to adjust to a quieter, truer frequency. In this state of profound relaxation, you can begin to perceive the invisible glue that binds the entire cosmos together, a phenomenon that quantum field theory calls entanglement. In our ordinary macroscopic experience, if you take a pair of dice, place them in a cup and roll them across a table, the outcome of one die has absolutely nothing to do with the outcome of the other. If the die on the left lands on a 6, the die on the right is still completely free to land on a 1, a 3, or a 5. They are independent systems, separated by a stretch of air, completely indifferent to each other's fortunes. This is what we call local reality, and it is the foundation of everything we consider common sense. But if you take two particles, two ripples on the same underlying field, and bring them close enough together to interact, they can form a bond that shatters this local common sense forever. They can become entangled. When two ripples become entangled, they lose their individual identities. They are no longer two separate waves traveling through space. They merge into a single unified quantum state, described by a single shared equation. If you then separate these particles, placing one of them in a laboratory in London and sending its twin to a laboratory on the far side of the moon, they remain intimately, instantaneously connected. If you perform a measurement on the particle in London, forcing its spread-out wave of probability to collapse, and choose a specific direction of spin, say spinning upward like a tiny top, its entangled twin on the moon will instantly, in that exact same microsecond, collapse into the opposite state, spinning downward. There is no delay. There is no travel time. The message does not travel across the gap of space between the Earth and the Moon as a signal passing through the air. If a laser beam were fired from London to the Moon to carry the news of the measurement, it would take more than a second to arrive, bound by the universal speed limit of light. But the entangled twin does not wait for a signal. It answers instantly, outrunning light itself, defying every classical rule of distance and separation. When Albert Einstein first noticed this mathematical consequence of the quantum laws in the 1930s, he refused to accept it as a literal description of reality. He famously dismissed it as spooky action at a distance, arguing that it was proof that the quantum theory was incomplete, a mathematical shortcut that was missing some hidden, deeper mechanism. He believed that the two particles must be like a pair of shoes that had been separated and placed into two identical boxes. If you open one box in London and find a left shoe, you instantly know that the box on the moon contains the right shoe, not because some magical signal traveled between them, but because the shoes were carved into those specific shapes from the very beginning. But in the decades that followed, physicists devised a series of incredibly delicate experiments to test Einstein's skepticism. They built automated laboratories that could measure entangled photons mid-flight, changing the settings of the measurement instruments after the particles had already left their source, ensuring that the particles could not secretly cooperate ahead of time. When the data came in, it revealed that Einstein was wrong. The shoes were not in the boxes from the start. Until the moment the box in London was opened, both boxes contained a fluid blur of potentiality, a wave that was simultaneously a left shoe and a right shoe at the same time. The act of measuring the first particle didn't just reveal a pre-existing answer. It forced the answer into existence, and its twin across the void responded to that choice in perfect, instantaneous harmony. This mystery loses its spookiness only when you return to the image of the universal oceans. The two particles are not separate objects traveling through a vacuum. They are 2 points on the same continuous sheet of water. Imagine a vast mythical sea monster sleeping deep beneath the surface of a dark ocean. The creature is so immense that its body stretches for miles across the seafloor. Every so often, it moves its limbs in the dark, and 2 of its green spikes break through the surface of the water at the same time, miles apart from one another. An observer standing on a ship, looking only at the surface of the sea, might look at those two spikes and see them as two independent things, completely separate from each other. But if one spike suddenly twists to the left, the other spike miles away will instantly twist to the right, because they are not two things at all. They are two expressions of the same single organism moving through the deep. This is the true nature of the space you are resting in tonight. Every cubic millimeter of the air, every atom of your body, is embedded in fields that are fundamentally interconnected. The apparent separation between objects is just a surface illusion, a consequence of looking only at the spikes above the water. At the deepest level of reality, the universe is a completely non-local canvas, an unbroken whole, where what happens in one corner is immediately felt by the rest of the fabric. You are not an isolated fragment drifting through a lonely void. You are a feature of a single, cosmic organism that is completely unified beneath the surface of things. As you let that sense of unity sink into your awareness, let your mind drift toward another great realization of the field-driven universe. The fact that light and matter are made of the exact same currency. In our daily lives, we treat light and matter as if they belong to two completely different kingdoms. Matter is heavy, solid, and durable. It is the stuff you can touch, the wood of your door, the metal of your keys, the bone of your hand. Light is fleet, weightless, and ethereal. It is the warmth that falls from the lamp, the color that paints the walls, the fleeting flash that vanishes as soon as the switch is flipped. We think of matter as the solid entities that inhabit space, and light as the fluid energy that moves between them. But quantum field theory reveals that this divide is completely artificial. Both light and matter are constructed out of the exact same material, excitations in a quantum field. The only difference between them is the specific name of the field that is vibrating today. When the photon field vibrates, it produces a ripple that we call a particle of light, a photon. When the electron field vibrates, it produces a ripple that we call an electron. When the quark field vibrates, it produces a quark. There is no fundamental difference in their texture. They are all waves in the same cosmic soup. And because they are made of the same currency, they can transform into one another with complete, fluid ease. Think about what happens when you turn on a simple, incandescent light bulb in a dark room. Inside the bulb, a thin filament of tungsten wire resists the flow of an electric current. As the electrons pack into the narrow wire, they collide with the tungsten atoms, shaking the field with an immense, white-hot intensity. That shaking disturbs the surrounding photon field, plucking its surface until trillions of new ripples break free, streaming outward through the glass of the bulb and filling the dark room with light. The energy that was just a moment ago a movement of matter, they are stacked on top of each other like different radio frequencies passing through the air of your kitchen right now. Your phone is catching a Wi-Fi signal, a local radio station is broadcasting a song through the walls, and a satellite signal is passing down through your roof, all occupying the exact same space without crowding each other out. The quantum fields of the universe live in this same intimate arrangement. When a ripple in the electron field wishes to move, it must often exchange energy with the photon field, the ocean that governs light and electromagnetic force. When the quarks that make up the protons in your bones want to stay bound together, they rely on the constant, frantic whispering of the gluon field. And as all of these ripples move through space, they wade through the thick, heavy drag of the Higgs field, which acts like an invisible, cosmic molasses, slowing them down, resisting their acceleration, and giving them the property we call mass. Without this constant dance between overlapping oceans, the ripples would fly apart at the speed of light. There would be no solid ground, no stars, no quiet rooms to sit in. But perhaps the strangest realization of this field-driven universe is what happens when you try to take the ripples away. In the old classical version of physics, if you wanted to find absolute peace, you simply had to build a perfect box. You would seal the walls so that no light could penetrate. You would attach powerful vacuum pumps to draw out every single atom of air. leaving behind an absolute void. Finally, you would cool the entire chamber down to absolute zero, the lowest possible temperature in the universe, a point where all thermal motion ceases, where every atom freezes into total unmoving paralysis. Under the old laws, that box would contain a pure, pristine nothingness. It would be a canvas with no paint, a theater with no actors, a state of perfect, absolute silence. But the universe does not allow silence. If you were to place an incredibly sensitive quantum instrument inside that frozen, dark, empty box, you would find that the vacuum is not dead. It is alive. It is shivering with a restless, permanent vibration that can never be turned off. This eternal restlessness is dictated by a fundamental law written down by Werner Heisenberg, the uncertainty principle. In the quantum language, nature operates under a strict system of balances. It rules that certain pairs of physical properties can never be settled at absolute zero at the same time. Energy and time live in this delicate embrace. You can never have a precise, absolute value of zero energy existing within a specific, measurable window of time. If a quantum field were to come to a complete dead stop, if its surface became perfectly flat, glassy, and still, it would possess an exact energy value of zero. The universe forbids this absolute certainty. To avoid breaking this fundamental law, the fields are forced to twitch. They shiver with what physicists call zero-point energy. Even at the coldest, most desolate point in deep space, at the absolute minimum energy state that reality allows, the fields remain on their lowest default setting, and that setting is a perpetual hum. Because of this hum, the vacuum becomes a crowded kitchen of creation and destruction. Out of the absolute dark of the empty box, tiny spontaneous ripples constantly arise. A tiny fluctuation in the field borrows a minute amount of energy from the vacuum, splitting into a pair of virtual particles, perhaps an electron and its positron twin. They flash into existence for a fraction of a billionth of a millisecond, take a single step through space, and then immediately collide with one another, canceling each other out and returning their borrowed energy back to the cosmic bank before any conventional clock can record their presence. This is happening right now in the empty air directly in front of your face. It is happening inside the dark spaces between the molecules of your brain. The vacuum is a boiling, simmering froth of ghosts, appearing and disappearing in an endless loop of quantum transactions. For decades, many conservative scientists treated this idea as a mathematical trick, a convenient way to balance equations on a chalkboard, but not something that belonged to the physical world we inhabit. That skepticism changed because of a Dutch physicist named Hendrik Casimir. In 1948, Casimir realized that if this ghostly shivering of the vacuum was real, it could be forced to reveal itself through a beautifully simple trick. He proposed taking two flat, polished metal plates and placing them incredibly close to one another inside a perfect, airless vacuum. They would not be touching. They would just be suspended a microscopic distance apart, a gap thinner than a fraction of a human hair. Think about what happens when ocean waves roll toward a narrow, rocky harbor. Large, rolling swells can easily crash against the outside of the cliffs, but only certain small, precise wavelengths can fit inside the narrow opening of the harbor itself. Casimir realized the exact same thing would happen to the shivering waves of the vacuum. In the vast, open space outside the two metal plates, the quantum fields can shiver at any wavelength they want. Infinite variations of virtual particles can pop into existence, creating a full, chaotic roar of quantum pressure pushing inward on the plates. But in the tiny microscopic gap between the plates, space is restricted. The long, rolling fluctuations of the fields simply cannot fit inside the narrow gate. Only the tiniest, shortest virtual waves can find room to vibrate between the two sheets of metal. This creates a subtle, beautiful imbalance. The quantum choir singing on the outside of the plates is louder, fuller, and more diverse than the quiet, restricted choir singing on the inside. The result is a gentle, persistent pressure. The emptiness on the outside pushes the plates together, squeezing them through the sheer, unadulterated force of nothingness. 50 years after Casimir wrote down his calculation, experimentalists finally built the nanoscale technology required to test his prediction. They placed gold-coated plates within 100,000th of an inch of each other inside a chilled, dark vacuum, isolating them from every stray electrical current and every vibration of the outside world. When they turned on their sensors, they watched the plates move. They were being pulled together by a fraction of an ounce, matching Casimir's mathematical formula with stunning precision. The Casimir effect remains one of the most haunting demonstrations in modern science. It is an undeniable, repeatable proof that empty space is not a void. It has a texture. It has a weight. It can reach out and physically move solid objects, because the fields that inhabit it are real, heavy, and permanently awake. When you look out into the night sky at the vast, black gaps between the stars, you are looking at the true engine of the universe. We tend to think that the interesting parts of the cosmos are the bright, burning points of matter. The suns, the planets, the swirling galaxies, the brilliant nebulae. We treat the empty space as if it is just the background canvas, the negative space around a drawing. But physics tells us that the canvas is where all the power lives. The matter we are made of is just a rare, fleeting decoration on a grand, restless ocean. If you could harvest all the energy locked up in the silent, invisible shivering of the vacuum inside a single empty coffee mug, some theoretical models suggest it would be enough to boil all the oceans on the planet Earth. The universe is not a sparse scattering of lonely things floating in a cold desert. The universe is an ocean of infinite potential, and we are just the foam gathering at the crest of its waves. As you drift closer to sleep, let your mind rest on the comfort of this profound connection. You are not an isolated traveler moving through a cold, indifferent void. You are not a separate fragment of matter bumping blindly into other fragments. The dark is never truly empty, and the deeper you descend into its silence, the more the old boundaries of the world begin to soften and blur. We have spent our lives believing that the skin on our arms marks a definitive border, a neat, unmistakable line where we end and the rest of the universe begins. We look at a stone resting in the grass or a book sitting on a nightstand, and our eyes tell us that these are lonely, self-contained islands of matter, separated from us by vast intervals of nothingness. But this separateness is a trick played on us by our senses. It is a slow-motion illusion born from the fact that our eyes are too large and our clocks move too slowly to see the true texture of reality. If we could magnify the space where your finger rests against the fabric of your blanket, the solid world would dissolve into a shimmering, fluid mist. You would see that your finger never actually touches the blanket in the way your mind imagines. Instead, as the atoms of your skin approach the atoms of the cloth, the electron fields of both surfaces begin to meet. They are like two intense, invisible weather patterns coming into contact. The ripples of your skin push against the ripples of the fabric, their waves resisting one another with an immense, stubborn force. That resistance is what your brain interprets as solidity. That electric push is what you call texture. Nothing ever truly touches. We are hovering. We are suspended on a cushion of quantum resistance. Waves sliding past waves. Fields whispering to fields in a language made entirely of force and frequency. To see how deep this fluid nature goes, we must return to that quiet room in England where Paul Dirac sat with his pen, staring at the double answer to his equation. When he realized that his mathematics required the existence of a mirror twin for the electron, he opened a door to a universe that was far more symmetric and far more precarious than anyone had ever dared to dream. The discovery of the positron was just the beginning. Within a few decades, physicists realized that the electron field was not the only double-sided sheet in the cosmic ledger. The quark field, which builds the heavy, solid cores of every atom in your body, has its own shadow side, an antiquark field. The neutrino field, filled with ghostly, near-weightless entities that stream through the entire Earth every second without hitting a single obstacle, is accompanied by a silent stream of antineutrinos. For every expression of matter, there is an equal and opposite expression of antimatter, waiting in the dark. This realization brought with it a haunting cosmic puzzle that takes us back to the very dawn of time. According to the laws of quantum field theory, when energy is converted into matter, it must always be done in perfect, flawless pairs. If you pluck a field hard enough with a flash of pure energy, you cannot simply create a single electron. The field will always yield both an electron and a positron, rising out of the vacuum together like twins born from the same breath. They are bound by an absolute law of balance. And yet, when we look out into the night sky with our most powerful telescopes, scanning the light of galaxies billions of light years away, we see a universe made almost entirely of ordinary matter. We see stars made of ordinary protons, planets made of ordinary silicon, and clouds of interstellar gas made of ordinary hydrogen. The antimatter twins are missing. They are rare, fleeting visitors caught only in the high-energy wreckage of cosmic ray collisions, or manufactured for brief, precious moments inside the magnetic traps of particle accelerators. This means that in the first frantic microsecond after the birth of the cosmos, when the universe was nothing but a screaming, blinding soup of overlapping fields at an unimaginable temperature, a quiet catastrophe took place. The fields were plucking each other with furious intensity, creating trillions of particles of matter and antimatter every single instant. It was a wild, white-hot furnace of creation and immediate destruction. Every time an electron met a positron, they would vanish back into the vacuum in a tiny, clean flash of light. Every time a quark met an antiquark, they would dissolve back into pure energy. The universe was erasing itself as fast as it was writing itself down. If the balance had remained perfect, the story would have ended right there. The cosmos would have settled into an eternal, expanding void, filled with nothing but a uniform, thinning haze of lukewarm light. There would have been no matter, no stars, no chemistry, and no life. But something subtle and unexplained broke the symmetry. A microscopic tilt occurred, a flaw in the cosmic machinery so small that it escapes our full understanding to this day. For every billion pairs of antimatter and matter particles that met and annihilated each other back into the dark, the universe somehow created one extra particle of ordinary matter. A single lonely survivor out of a billion casualties. As the universe cooled and the great annihilation came to an end, all the antimatter vanished into light, leaving behind only that microscopic tilt. That 1 in a billion leftover residue is everything you see today. Every grain of dust in the solar system, every mountain range on Earth, every drop of water in the deep oceans, and every cell in your beating heart is made from that tiny, asymmetrical scrap of matter that survived the dawn of the world. We are the beautiful, accidental debris of a broken balance. And yet, the oceans that allowed that ancient storm to happen have not changed. They are still here, lying perfectly flat and deceptive in their stillness, filling the very room where you are drifting off to sleep. The antimatter side of the field is not gone. It is merely resting in its lowest energy state, waiting for a sufficient disturbance to wake it up. Every time a hospital turns on a PET scanner to locate a tumor inside a patient's body, they are gently waking up that shadow side. The machine relies on a radioactive isotope that decays by emitting a single positron, a genuine piece of antimatter, directly into the patient's tissues. That positron travels for less than a millimeter before it encounters one of the ordinary electrons inside the patient's cells. When they meet, the old ancient law of the universe takes over. The two ripples cancel each other out, collapsing back into the underlying fields, and release their remaining energy as two identical gamma-ray photons that fly out of the body in opposite directions. The scanner catches those flashes of light, traces them back to their source, and maps the interior of the flesh. It is a medical miracle that performs a deep, philosophical ritual every second it operates, using the annihilation of matter and antimatter to preserve a human life, proving that the strangest laws of deep space are active inside our own bodies. To understand how these fields manage to hold their shapes long enough to build a world, we have to look closer at the concept of a wave. In our everyday experience, waves are sloppy, fleeting things. If you splash your hand in a bathtub, the ripples move away from your fingers, hit the edges of the tub, break apart, and quickly dissolve back into a flat surface. They do not stay put. They do not form structures. How, then, can an electron field be made of waves if an electron can sit quietly inside a copper wire or stay bound to a single carbon atom for billions of years? The answer lies in a beautiful phenomenon known as a standing wave. Imagine taking a long, heavy rope and tying one end of it securely to a tree. If you take the free end in your hand and give it a single, sharp jerk upward, a wave will travel down the length of the rope, hit the tree, and bounce back toward you. That is a traveling wave, moving through space, like the light from a distant star. But if you begin to move your hand up and down rhythmically, at just the right speed, something beautiful happens. The waves traveling toward the tree begin to meet the waves bouncing back toward your hand. They pass through each other, and if your timing is precise, they lock into a permanent pattern. Suddenly, the rope no longer looks like it is traveling anywhere. Instead, it appears to be vibrating in place, dividing itself into clean, stationary loops. There are points along the rope that shake violently up and down, and other points, called nodes, that stay perfectly still. Pinned in space by the perfect balance of opposing forces, the wave has stopped moving through space. It has become a structure. It is a shape made of nothing but pure, continuous motion. This is what happens to an electron when it is caught by the attraction of an atomic nucleus. It is not a tiny planet orbiting a sun, as the old, outdated textbook drawings used to suggest. A planet has a definite location. You can point to it and say it is exactly here at 4 o'clock and exactly there at 5 o'clock. An electron does not do this. When an electron field is pulled in by a proton, the wave wraps around the center and collapses into a three-dimensional standing wave. It becomes a soft, pulsing shell of probability, a vibration that fills a specific volume of space all at once. Physicists call these vibrant structures orbitals, but it is far more accurate to think of them as the natural harmonies of an atom. Just as a violin string can only play certain specific notes depending on its length and tension, an electron field wrapped around a nucleus can only vibrate in certain specific shapes. It can form a simple, perfect sphere. If you give it more energy, it can split into a shape that looks like a delicate hourglass, or a cloverleaf with 4 distinct loops, or a complex ring suspended in space like a small, ghostly donut. These shapes are not boundaries made of a solid material. There is no hard crust protecting the atom. The shape is simply the pattern of the vibration itself. When you look at a drop of water sitting on a loudspeaker that is humming at a low frequency, the water will suddenly form geometric ridges and valleys, shifting into beautiful, steady mandalas of fluid movement. The water hasn't changed into a solid. It has simply been organized by a sound wave. That is what you are. That is what your room is. You are a vast collection of overlapping mandalas, carved into the invisible oceans of space by the deep, silent chords of quantum mechanics. Because these electron ripples are soft and fluid, they can do things that defy every rule of common sense. In our macroscopic world, if you throw a tennis ball against a brick wall, you know exactly what will happen. The ball will hit the solid surface, flatten slightly, bounce back, and land at your feet. It does not matter if you throw it 100 times, 1,000 times, or 1,000,000 times. The ball will never pass through the wall unless it has enough energy to smash the bricks apart. The barrier is absolute. But in the subatomic world, where the boundaries are made of waves, the wall is not absolute. Imagine an electron traveling through a circuit, approaching a thin electrical barrier, a microscopic layer of insulating material that it does not have enough energy to cross. According to the old, mechanical view of physics, the electron should bounce back every single time, stopped cold by the law of conservation of energy. But because the electron is a spread-out ripple on a field, its wave-like nature behaves differently. When a wave hits a thin barrier, it doesn't just stop instantly at the front surface. The wave penetrates the material, its intensity decaying exponentially as it travels through the dark interior of the wall. If the barrier is thin enough, a tiny, faint fraction of the wave will actually manage to leak out the other side before it dies away entirely. The wave on the far side of the wall may be incredibly small, a mere whisper of a ripple, but it is not zero. And because the intensity of a quantum wave represents the probability of finding a particle, that tiny leak has a profound meaning. It means there is a real, measurable chance that the electron will suddenly manifest on the other side of the solid barrier without ever having traveled through the middle of it. Physicists call this quantum tunneling, and it sounds like a fantasy, a science fiction trick that belongs in a story about ghosts passing through walls. But it is a cold, hard fact of nature that operates at the center of our modern technology. Every time you save a photo or a video onto a flash drive or a solid-state hard drive, your computer is using quantum tunneling to push electrons through insulating barriers, trapping them in tiny, microscopic cells of silicon to store your memories as binary code. If the electron were a hard, solid ball, your smartphone would not work. The digital world relies entirely on the fact that matter is fluent enough to leak through walls. And the universe relies on it too. Deep inside the core of the sun, where the temperature is measured in millions of degrees, hydrogen atoms are packed together under an immense, crushing pressure. They want to fuse together to form helium, a process that releases the brilliant, life-giving light that warms our planet. But there is a massive obstacle in their way. Every hydrogen nucleus carries a positive electrical charge, and positive charges repel each other with an intense, furious force. Left to themselves, the nuclei can never get close enough to touch. The electrical barrier between them is too high, even in the roaring furnace of the solar core. If the universe were made of solid balls, the sun would never have turned on. It would be a dark, cold, dead ball of gas, has transformed seamlessly into a movement of light. The fields have simply handed their vibrations from one layer of the tapestry to the next, like a secret passed from one dancer to another in the dark. This constant translation between light and matter is happening inside your own eyes at this very moment. As your eyes adjust to the darkness of your bedroom, the few remaining photons of light reflecting off the ceiling are falling onto your retina. When a photon hits a specialized molecule inside your visual cells, its energy plucks the electron field of the atom, causing an electron to jump to a higher standing wave pattern. That jump triggers a tiny, microscopic domino effect, a cascade of electric signals that travels along your optic nerve and into your brain, where your consciousness interprets it as a faint shape in the dark. The light has become a thought. The ethereal ripple has become a physical reality inside your nervous system. There is no wall between the outside world and the inside world. They are two sides of the same continuous loop of field interactions, a single conversation whispered across the overlapping oceans of space. And as you listen to that conversation, you can begin to feel the profound peace that comes from knowing that your body is completely transparent to the largest fields in the cosmos. We tend to think of our bodies as armor, a solid defensive wall that protects our inner life from the wilderness of the outside world. We lock our doors, close our windows, and wrap ourselves in blankets to keep out the cold, believing that we can isolate ourselves from the forces of nature. But there are fields in the universe so immense and so subtle that our solid walls and our physical skin mean absolutely nothing to them. They pass through us as if we were made of pure glass. Consider the neutrino field. Neutrinos are the ghosts of the subatomic world, minuscule ripples that possess almost no mass at all, and carry no electrical charge. Because they do not interact with the electromagnetic field, they are completely immune to the forces that make regular matter feel solid. They do not bounce off the atoms of your skin. They do not hit the furniture in your room. They do not care about the concrete foundation of your house. Right now, as you lie in your bed, a roaring, invisible river of neutrinos is streaming down from the sky, produced by the nuclear furnaces of the stars and the cosmic collisions of deep space. Trillions of them are passing through your head, through your chest, through your mattress, every single second. They slide through the entire planet Earth, as if it were a sphere of clear air, exiting the far side of the globe and continuing their endless journey into the dark wastes of the cosmos without ever slowing down, without ever leaving a scar, without ever waking you from your sleep. You are not an obstacle to the universe. You are a space through which the universe is flowing. Think of a wire cage suspended in the middle of a fast-moving mountain stream. The water rushes in through the metal mesh on one side, flows around the wires, and pours out the other side, completely unhindered by the presence of the cage. The water inside the cage is the exact same water that was just a moment ago, tumbling over the rocks upstream, and the exact same water that will a moment from now be rushing down into the valley below. The cage does not separate the water. It simply encloses a temporary volume of the current for a brief moment in time. Your body is that wire cage. You are a temporary enclosure in the middle of a continuous, cosmic stream. The fields that make up your cells are not trapped inside your skin. They are a part of the great universal current that flows through everything, everywhere, all at once. The particles that build your heart tonight were once part of a cloud of gas drifting between the stars, and they will one day break free to build new oceans and new worlds in a future you will never see. You do not own the material of your life. You are simply borrowing it from the vacuum for a short, beautiful season before returning it to the grand ledger of the cosmos. Let that transience wash over you as a profound source of relief. You do not need to hold yourself together with such fierce waking effort. You do not need to defend your boundaries against the universe, because the universe is not an enemy invading your territory. It is the very medium in which you live and move and have your being. When you let go of your waking control and allow yourself to fall asleep, you are not disappearing into a void. You are simply allowing the wire cage of your identity to loosen its grip, letting the current carry you back into the great collective harmony of the deep. The breathing of your chest is slowing down now, settling into a steady, rhythmic cadence that mimics the slow expansion of the space around you. With every breath you take, imagine that you are expanding with the fields, widening out beyond the limits of your room, beyond the roof of your house, beyond the contours of the earth itself. You are rising into that high, cold stillness where the atmosphere thins into the pure vacuum of the solar system, the place where the fields are stripped of all the noise of human life, left alone to shiver in the pristine, starlit dark. Up here, in the great open plains of the cosmos, the oceans of space look completely different. The electron field stretches out like a smooth, unbroken mirror of dark glass, waiting for the birth of new suns. The photon field hangs like a delicate, transparent web, catching the ancient light of galaxies that died before the Earth was born. And the Higgs field sits like a deep, patient weight, anchoring the geometry of the universe to the silent laws of nature. There are no clocks up here. There are no schedules. There is no rush. There is only the eternal, majestic rhythm of the quantum dance, the constant appearing and disappearing of virtual worlds, the silent exchange of energy between overlapping dimensions, the patient weaving of the cosmic tapestry. You are a native citizen of that high stillness. The hectic, noisy world of your daytime life is just a temporary ripple on the surface of this deeper eternity, a brief splash that is over almost as soon as it begins. When you look at your life from the perspective of the fields, your worries lose their sharp, stinging edges. The mistakes you made today, the anxieties you have about tomorrow, the small daily frustrations that seem so large when the sun is up. All of them are just microscopic fluctuations in a localized corner of a grand, indestructible fabric. They cannot tear the cloth. They cannot drain the ocean. They cannot silence the beautiful, eternal hum that keeps the universe alive. Let your mind rest on the absolute durability of that fabric. The universe has never lost a single ounce of its energy. It has never misplaced a single particle. It has never broken a single law. Every event in its long 14 billion-year history has been recorded with perfect, mathematical fidelity in the structure of the fields. And that structure is completely safe. It cannot be destroyed by time. It cannot be corrupted by decay. It cannot be forgotten by the vacuum. You are a permanent part of that architecture, a stitch in a tapestry that can never be unraveled, a note in a song that will be played until the end of time. Allow that security to wrap around you like a heavy velvet blanket, pressing down on your limbs, smoothing out the lines on your forehead, relaxing the muscles around your eyes. Your thoughts are becoming distant now, like the faint, twinkling stars at the edge of the horizon. They are losing their words, turning into slow, drifting shapes that float across the dark canvas of your mind without ever leaving a footprint. You do not need to follow them. You do not need to catch them. Let them drift. Let them fade. Let them disappear back into the quiet reservoir from which they came. The electron field inside your brain is quieting down, its frantic daytime currents settling into the long, slow, rolling waves of deep sleep. The photon field inside your room is completely dark, its strings at rest, its music silent, waiting for the dawn. And the Higgs ocean is holding your body in its heavy, tender embrace, pinning you to the earth with a gentle, stubborn force that says you belong here, you are welcome here, you are a part of this world. For generations, science relied on a clean, architectural narrative. If you took an apple and sliced it in half, you still had an apple. If you kept slicing it down, past what the human eye could resolve, you would eventually find the fundamental units, the Greek atomos, meaning that which cannot be cut. When modern physics finally managed to peer inside the atom, they found smaller parts, a dense nucleus orbited by electrons. The textbooks drew them as tiny planets circling a tiny sun. It was a neat, orderly picture. If you smashed those parts together at high speeds, you found even smaller fragments, quarks, gluons, leptons. The assumption remained the same. If you go deep enough, you will find the ultimate, hard, indivisible pebble of existence. But in the quiet corners of 20th century laboratories, this entire worldview began to crumble. The marbles refused to act like marbles. Imagine taking a handful of fine sand and throwing it at a doorway with two narrow vertical openings. On the wall behind the door, you would naturally expect to see two vertical piles of sand corresponding exactly to the shapes of the openings. That is how independent, solid objects behave. They travel along straight, predictable paths. When physicists performed this exact experiment with electrons, firing them one by one through two microscopic slits toward a sensitive detector screen, they expected to see two distinct lines. At first, each electron landed as a solitary, sharp dot. It looked like a tiny bullet hitting a target. But as hundreds, then thousands of individual electrons were fired over hours of quiet observation, something impossible happened. The dots didn't form two neat columns. Instead, they organized themselves into an intricate pattern of alternating stripes, bright bands separated by dark, empty spaces. This was an interference pattern. It is the unmistakable signature of a wave. It is the pattern you see when two stones are dropped simultaneously into a still pond, and their expanding rings crash into one another, amplifying the crests in some places and flattening the water in others. Think about the profound strangeness of this moment. The electrons were fired one at a time. Each electron left the source before the next one was even conceived, There were no other particles in the chamber for it to collide with or crowd against. Yet, a single electron, traveling through the darkness entirely alone, somehow passed through both slits at the same time. It interfered with itself. It mapped out a path governed not by the geometry of a bullet, but by the fluid dynamics of an invisible tide. The hard marble of classical physics had dissolved into a phantom wave. The particle was no longer a thing. It was a probability, a ripple spreading through space, aware of its entire environment all at once. Dirac's mirror and the discovery of the tapestry. The second radical shift came from a young, intensely quiet theoretical physicist from Bristol named Paul Dirac. In the late 1920s, Dirac sat alone with his mathematics, trying to solve a fundamental contradiction that threatened to tear physics apart. He needed to reconcile the strange new rules of the subatomic world, quantum mechanics, with Albert Einstein's theory of special relativity, which dictates how objects behave when they move near the speed of light. Dirac wasn't looking to reinvent the cosmos. He was simply looking for a mathematical bridge. He wanted an equation that could describe the behavior of a high-speed electron without violating the laws of space and time. After months of intense, solitary focus, he found it. He wrote down a remarkably elegant equation. It described the electron with unprecedented accuracy, seamlessly incorporating its mass, its negative charge, and its intrinsic magnetic spin. But mathematics is a mirror that often reflects more than its author intends. As Dirac studied his equation, he noticed a deep, unsettling feature. Like the algebraic equation, which has two correct answers, Dirac's formulation possessed two distinct mathematical solutions. The first solution mapped out the ordinary electron perfectly. The second solution described an entity with the exact same mass, the exact same spin, but with a completely inverted, positive electric charge. At first, Dirac dismissed it as a mathematical anomaly, a ghost in the gears of the algebra. No such particle had ever been seen in the history of science. The only positively charged particle known at the time was the proton, but a proton is nearly 2,000 times heavier than an electron. The math was unyielding. This mystery entity had to be a perfect weight twin of the electron, only mirrored in its essence. Dirac eventually realized that his equation was not describing a solitary, isolated particle at all. It was describing an all-encompassing underlying medium, a universal field. The particle was just a localized disturbance in that medium, and the math was revealing that the medium could be disturbed in more than one direction. In 1932, a physicist named Carl Anderson was studying cosmic rays, high-energy radiation raining down from deep space, using a specialized cloud chamber in California. In his photographs, he captured a faint, unmistakable vapor trail left by a cosmic traveler. It had the exact mass of an electron, but it curved the opposite way under the influence of a magnet. It was Dirac's mirror twin, caught in the real world. We call it the positron, the first confirmed piece of antimatter. The revelation of antimatter changed everything. It meant that particles could be created out of nothing, and they could be destroyed completely. When an electron meets a positron, they do not simply collide like billiard balls. They instantly vanish in a spectacular flash of pure energy, leaving behind nothing but two photons of light. If a particle can be annihilated, if it can dissolve back into light, then it was never a fundamental, permanent object to begin with. It was an event. It was a temporary modification of something deeper, the cosmic oceans. To understand what physics now knows to be true, we have to discard our everyday language and embrace a new way of seeing. Imagine walking out to a completely dark, glassy lake at midnight. The water is so still and the night is so black that you cannot see the lake itself. It is invisible to your eyes. Suddenly, a fish breaks the surface far out from the shore. A circular ripple expands outward across the water, catching the faint starlight for a few moments before fading back into the stillness. You point your finger out into the dark and you say, "Look, There is a thing moving across the lake, but what is that thing actually made of? It isn't made of a separate piece of matter that traveled from the center of the lake to the edge. The ripple is made of the lake itself. The water didn't travel, it merely moved up and down. The thing you observed was not an object. It was a localized behavior of the water. This is precisely what quantum field theory reveals about our universe. The cosmos is not an empty room containing particles. The cosmos is a collection of invisible, infinite fluid oceans layered directly on top of each other, permeating every single cubic inch of reality. These oceans are called quantum fields. There is an electron field. It stretches across the entire expanse of space. It is inside your heart right now. It is inside the frozen crust of Pluto. It is spanning the immense, lonely gaps between distant superclusters of galaxies. It is a single, continuous, unbroken entity. When the universe injects a little bit of energy into this invisible ocean, the ocean stirs. It creates a tiny localized ripple. And when our instruments detect that specific ripple, we call it an electron. There is another ocean layered in the exact same space, the photon field, which carries the vibration of electromagnetism and light. There is a quark field, which shimmers to create the dense interiors of atomic nuclei. There is a Higgs field, which acts as a cosmic molasses, giving weight to the ripples of the other oceans as they move through it. These fields are not mixed together like a soup. They do not displace one another. They coexist simultaneously in the exact same place, at the exact same time, completely independent, yet profoundly interactive. Think of it like the air in the room you are resting in right now. That air is currently filled with hundreds of different radio waves, Wi-Fi signals, television broadcasts, and cellular data streams. They are all passing through the same space at the same moment. A radio tuned to one frequency picks up a symphony. A cell phone tuned to another picks up a voice. They do not collide or disrupt one another because they exist on different vibrational channels. Your body is a spectacular convergence of these channels. When you move your hand through the air, you are not moving an object through nothingness. You are a dense, highly organized cluster of ripples passing through a series of cosmic oceans, gently perturbing them as you glide along. You are made of the very same fluid stuff as the space you are traveling through, the restless void and the shiver of nothingness. For thousands of years, the human mind associated the vacuum of space with absolute non-existence. We imagined that if we took a stout steel box, pumped out every single atom of gas, shielded it completely from external radiation, and cooled it down to the absolute bottom of the temperature scale, we would be left with a pure, pristine pocket of absolute nothingness. But quantum mechanics introduced a radical roadblock to this idea, formulated by a young German physicist named Werner Heisenberg. His famous uncertainty principle discovered that nature enforces a strict limit on how precisely we can know certain aspects of reality at the same time. One of those fundamental pairs is energy and time. The universe behaves like an unyielding accountant that refuses to let the energy of a field drop to an absolute, definite zero for any measurable duration of time. If a field were to become perfectly still, perfectly flat, and completely devoid of energy, it would possess a precise value, 0, over a precise duration. This is strictly forbidden by the mathematical laws of our reality. Because fields are legally barred from being completely still, the vacuum can never be empty. It is forced to shiver. Even in the deepest, coldest, most shielded void imaginable, the quantum fields maintain a baseline restlessness. They tremble with what physicists call zero-point motion. It is the absolute lowest vibrational setting of the cosmos, and that setting is an eternal, low-frequency hum. Out of this silent hum comes an extraordinary phenomenon: virtual particles. Because the energy of the field fluctuates wildly on unimaginably small timescales, The field constantly borrows tiny fragments of energy from the space-time fabric to create pairs of ghost-like ripples. An electron and an anti-electron will spontaneously materialize out of the dark vacuum, exist for a fraction of a billionth of a trillionth of a second, and then collide and annihilate each other, returning the borrowed energy back to the cosmic bank before any instrument can catch them in a definitive act. This isn't just a convenient mathematical trick used by theorists to balance their books. It is a physical reality that leaves real, indelible marks on our world. In 1948, a brilliant Dutch theoretical physicist named Hendrik Casimir realized that this relentless quantum shivering could be harnessed to move physical matter. He proposed a deceptively simple experiment. Take two perfectly flat, highly polished metal plates and bring them incredibly close together inside a total vacuum, separated by only a microscopic fraction of an inch. Casimir reasoned that the vast open space outside the plates would allow virtual waves of all possible sizes to fluctuate freely. But the tiny claustrophobic gap between the two plates would act like a restrictive musical chamber. Only virtual waves that could fit perfectly into that narrow distance could pop into existence inside the gap. Long, sweeping waves would be completely locked out. This creates a subtle, beautiful imbalance. The infinite choir of virtual particles fluctuating on the outside of the plates creates a slightly greater pressure than the restricted choir on the inside. The result? The two plates should be gently, inexorably pushed together by the sheer weight of empty space. For decades, the technology required to measure such an infinitesimal force did not exist. But in the late 1990s, experimentalists finally managed to construct the precise apparatus. They placed gold-coated surfaces a mere fraction of a hair's width apart in a completely silent vacuum chamber. When they turned on their sensors, they watched in awe as the plates began to move on their own. They were drawn together by a tiny, stubborn, persistent force that matched Casimir's mathematical calculations down to the decimal point. Think about what this truly means. If you sit in a dark, quiet room tonight, the space all around you is not empty. It is a boiling, churning cauldrons of potential. The vacuum is alive with a ghostly pressure, humming at the very edge of existence, exerting a real, measurable force on the physical world. The illusion of singularity, the one-electron universe. Because we are accustomed to looking at the world through the lens of individual things, we view ourselves as isolated beings separated from the rest of the cosmos. We see an electron in our finger as a completely separate entity from an electron spinning inside a hydrogen atom in the atmosphere of Jupiter. But in the spring of 1940, at Princeton University, a brilliant and notoriously unconventional physicist named John Wheeler called his young graduate student, Richard Feynman, late at night with a wild, intoxicating idea. Wheeler said, "Feynman, I know why all electrons have the same mass, the same charge, and the same identical properties everywhere in the universe." Feynman asked how. Wheeler replied, "Because they are all the same electron." Wheeler's whimsical hypothesis was that a single, solitary electron was weaving its way forward and backward through the fabric of time, traveling to the end of the universe, turning around, changing its charge to become a positron, traveling backward to the dawn of time, and repeating this cosmic zigzag indefinitely. Every time this single traveler crossed our specific moment in the present, we perceived it as a completely distinct electron. The trillions of electrons in your cells, in the oceans, and in the furthest quasars were, in Wheeler's eyes, just different glimpses of the very same lonely actor on a vast, multi-dimensional stage. While the one-electron universe remains a beautiful, poetic piece of science fiction, the profound problem it sought to solve is answered directly and elegantly by quantum field theory. Why is every electron in the cosmos absolutely identical? In our macro world, No two snowflakes are completely alike. No two grains of sand possess the exact same arrangement of facets. Yet, every single electron in existence, whether it was formed in the intense heat of the Big Bang or born yesterday in a particle accelerator, carries the exact same mass of kilograms and the exact same negative charge without a single atom of variation. QFT tells us that they are identical because they do not belong to separate objects. They are all individual waves born from the exact same ocean. If you look at the Atlantic Ocean during a storm, you might see 10,000 distinct whitecaps rising above the dark water. They look like individual entities, moving separately, crashing at different times. But they are not independent things. They are all just different expressions of the single, unified body of water beneath them. Every electron in your body is directly connected to every electron in the heart of the sun, because the electron field that supports them both is one continuous, unbroken fabric spanning the entirety of creation. There is no such thing as empty, isolating space. We are all deeply structurally knitted into the same universal medium. The soft architecture of matter. As we sink deeper into this realization, our old intuition about our own physical bodies begins to change. We think of our cells and bones as solid structures that occupy space and keep the world out. But if you look at a simple atom, say a hydrogen atom, the old textbook model of a hard little electron ball whizzing around a solid proton nucleus is completely false. If you could zoom into the electron inside an atom, you wouldn't find a localized point moving along an orbit. You would find a standing wave. Think of a wine glass. If you moisten your finger and rub it gently along the rim, the glass begins to sing. If you look closely at the surface of the wine inside, you will see a beautiful, intricate geometric pattern of shivering waves. The water isn't spinning around the glass. The entire body of water has taken on a specific, vibrating shape based on the frequency of the sound. That vibrating shape is exactly what an atomic orbital is.